Hi class, just going to, unfortunately can't be with you today, but you'll have to excuse my. So in this video, I'm going to go through some notes, equations review, and if I can get you to complete your notes as we go, and also copy a little bit of into your books after the video, and your heading is equations review, 7A. So I'm going to briefly talk about an equation and that an equation or a statement can be true or false. Understand that a solution is a value in which the unknown makes the equation true. So we can guess and check, and we'll also go into another way to solve equations. Find a solution by inspection, so guessing and checking, and getting closer and closer to the solution, and to be able to write equations using worded description. All right, so let's start off with this. If we've got let's say that we've got an equation and we need to find a number to make this true. So let's have a look. I've got 25 is equal to B times 10 minus B. Now we're just going to do some guess and check. So let's say if I say that B is equal to 1. And if I throw B is equal to 1 here, we've got 1, 10 minus 1. Does the left-hand side equal the right-hand side? Well, if I go ahead and throw in a B equals 1, I'm going to get 25 is equal to, well, this is a B, I'm going to replace it with a 1. And you can see here that 10 take 1. Clearly the left-hand side's 25, but does it equal the right-hand side? Well, let's do inside the brackets. 10 take 1 is 9. 9 take times 1 is 9. But does 21 equal 25? Does it equal 9? No, it doesn't. That's what we call false. So clearly B equals 1 is not the solution to this. You could keep going. We could go to 2. No, it doesn't. 3. No, it doesn't work. We might be getting closer and closer to the solution though. So for example, if I was to say B is equal to 3, and I substitute that into the equation, wherever there's a B, I'm going to replace it with a 3. Gee, I was a poet and I didn't even know it. Let's have a look. 25 on the left-hand side, but the right-hand side, 3 times what's in the brackets, 10 take away 3 is 7, is 21. We're getting a little bit closer. Now, if we could keep going. B equals 4 doesn't work. Let's try B is equal to 5. So let's try B is equal to 5. If B is equal to 5, we would have 5 times 10 take away B, which is 5. Does that work? 25 is equal to 5. Inside the brackets is 5. 5 times 5 is, of course, 25. Look, the left-hand side equals the right-hand side. So we've actually, just by guessing and checking, we've found a solution. And that is that B equals 5. Okay, so this is actually true. This makes the equation true. So therefore, that's my solution. Okay, so of course, how do we find that prove this is a solution? Well, we obviously have to find what we do a bit of guessing and checking and find out what our solution is. And you can see that it makes both the left-hand side and the right-hand side match up. Now, can we try and find a solution to 11 times B equals 11 plus B? Okay, so let's try it. Let's try a few things. Let's say 11 times if B is 1. If B is 1, we'd have 11 times 1. Does that equal 11 plus 1? Not quite. Does 11 equal 12? No, it doesn't. So that's what we call, that's a false statement. We could keep going. We could go 11 times 2. Does that equal 11 plus 2? No, it doesn't. Let's work our way through this and see what we can get. Now, you could try a number of things. Let me just say that this is not a whole number. So guessing and checking will only get you. So I think we really want to make a point that guessing and checking will only take you so far. So if I've got this, I want to find a solution. Now, if 11 times b, we could write that in algebra. We can write this in algebra as 11b. And on the right, we've got 11 plus b. Well, what we can do, though, if we want to get the b's on one side, we could say, okay, look, I've got a b over here, and I want to get it to the other side, so I'm going to do what we call the inverse of adding b, and we're going to subtract b. Okay, now if I subtract b from both sides, 11 take 1 is 10, and that would leave us with 10b. And on the right-hand side, b take away b, if you like. This is, if I was to take away b, the reason why we're doing this is we want to sort of cancel it from this side. So in actual fact, our answer with a more robust sort of way of doing things is 10b is equal to 11. Well, what times 10 gives us 11? Well, I could get a calculator out. Or what we could do is, look, notice here that b is multiplied by 10. So if I go back to BODMAS, okay, we're looking at sort of a two-step problem here. And when we evaluate things, we work our way down. But when we solve, we're actually working our way up. Now, obviously, we're doing what's called inverse operations. So I want you to start thinking about this is sort of where we're heading is inverse operations, because guessing and checking work quite well for this example, because it was a nice whole number, and we found by guessing and checking that b is equal to 5 is a solution. In this case, what times 10 gives me 11? Well, let's do the inverse then. You can see that b is multiplied by 10. So if we've multiplied by 10, can you see there we've got division and multiplication. They're the inverse of each other. So the opposite of timesing by 10, so we can see here we've multiplied by 10. We multiply by 10. I want to get and cancel out that b, so I want to do the opposite with it, which is divide. So the opposite of times by 10 is divide by 10. So if I divide by 10 on both sides, divide by 10, that's going to cancel that out. And in actual fact, our solution is going to be 11 over 10, which if you think about it, if I have 11 and I divide by 10, we can go back one decimal point. Look at that, 1.1. So 1.1 is our solution. It's not always going to be nice whole numbers. So later on, we want to be looking at this method here, using inverse operations to solve these, and get away from what we're probably most likely doing in year 7, which was just guessing and checking. It only sort of takes us so far. All right, girls. Now, just quickly, can I, at the end of this video, can I get you in your notes, please? The heading is 7A, Equations Review, and I would like you to copy down this theory, Equations Review. All right, and of course, it looks about, if two things are equal, two expressions are separated by an equal sign, and what we want is we want the left-hand side to equal the right-hand side, and that's going to make what we call an equation a true statement, and that's what we're looking for. All right, so I'll get you to jot that down into your book after this, after I go through a few more examples. All right, so let's have a look at some of what we're going to be encountering in our text questions. True or false? So what we're going to do is we're going to identify for each of these equations, state whether they're true or false. Okay, let's have a look and start with the left-hand side. You can see the left-hand side of A is 3 plus 8, which of course is 11. What we're going to do is marry up the left-hand side and the right-hand side and decide, are they both the same? Is 15 take 4, which is the right-hand side, is that also 11? Yes, it is. So that means that we've got a match. We've got the left-hand side and the right-hand side, which means that we have what we call a true equation. This is going to lead to other things later on. Let's have a look at this B. We've got 7 times 3, which is the left-hand side, which of course is 21. And let's have a look at the right-hand side. We've got 20 plus 5, which of course is 25. Does the left-hand side match the right-hand side? No, it's not. So this is false. In other words, is 21 equal to 25? Is that garbage? Yes, it is. It doesn't equal 25. So it is therefore false. For C, we've got this x plus 20 is equal to, it's a bit more complicated, this one, 3 times x. It says if x is equal to 10, and that's what we're doing. When we're guessing and checking, that's really what we're doing. We're substituting that into the equation. So let's replace x with 10. Does 10 plus 20, does that equal 3 times 10? Well, the left-hand side, 20 plus 10 is 30. The right-hand side is also 30. So we've got a match. We've got true. That means that if we've got a match, then that means this is our solution. Our solution is x is equal to 10 because it's true. If it's not, if it's false, if the equation has a, contradiction, we'll call it. So if I have, over here I had 21, does 21 equal 25? No, it doesn't. So that would be false. So if the equation has, a contradiction, something goes wrong, then it is false. And we're going to have to start guessing and checking and finding some other solutions. All right, some more examples. Now let's start. We can probably just guess and check these. So if we work our way through these, what would be my solution? What would make this true? What would make this equation true? You've probably already guessed it. What could x be to make the right-hand side 25 or the left-hand side 25? So I've got 4 plus something is 25. Well, clearly that would be, x would have to be equal to 21, wouldn't it? Because 21, if I have 4 plus 21, that is equal to 25. That's the left-hand side. Does that equal the right-hand side? Yes, it does. We've got a match. So my solution, just by guessing and checking, is x equals 21. Now, where we're heading, this is what we call a one-step equation. And let's go back to good old BODMAS. And when we evaluate things, we evaluate working our way down. When we solve, we're sort of working our way up. So let's start thinking about big picture. We want to solve this way. How could we do that? Well, let's think about it. We want to isolate x. We want to get x by itself. You notice that x there's a 4 added to it. So if I look at addition and subtraction, well, we've got an addition. So what is the opposite to add? It is subtract. So let's go ahead and try this another way. Without guessing and checking, I reckon you can do this for these one-step problems. So I've got 4 plus x is equal to 25. I want to isolate x. I want that to be by itself. So what we're going to have to do is we've got add x, we've got to add 4. We've got to do the inverse of adding 4, which is subtract 4 from both sides. And you'll see that when I subtract 4, if I subtract 4, that sort of cancels out that 4. And we're left with x. Remember, I've got to do a balancing act. Whatever I do to the left, I've got to do to the right, otherwise I've caused an imbalance. So 25 take 4 is 21. You can see that we've done that without a guessing and checking. And yes, we can guess and check for something like this. And likewise, let's have a look over here. What times 5 is 45? You probably guessed it, hopefully. We know that 5 nines are 45. So that means that my solution would be y is equal to 9. But if I would wanted to tackle it another way, we're multiplying y by 5. So let's have a look. We've got division and multiplication are an inverse of each other. So if I'm multiplying by 5 and I want to cancel that out, let's do the opposite. That's going to be divide by 5. If I do it to the left, it's like a seesaw. If I subtract 5 from, if I divide this left-hand side by 5, I've got to do the same to the right-hand side. Otherwise, I've created an imbalance. So let's do that. Let's write it out. 5y divided by 5 is a fraction. 45 divided by 5. Now, what you should notice is I'm multiplying y by 5. And look at that. Those 5s are going to cancel out. I'm left with this y. Just these simple one-step problems. So you can certainly start to think about it in a different way. 45 divided by 5 is 9. So that is another way of doing it. Yes, I give you permission to guess and check, but I hope now that we're moving into year 8, we start to think about some new ways of tackling these. Again, with this one, what number? You probably think about it. If I started at 5, let's do the guess and check way. Let's do guess and check. And let's start at 5. Let's see, does 5 work? 3 times z is 5. Is that true? Okay, 3 times 5 is 15. Is this garbage? Is this a garbage statement? Is 26 equal 20? No, it does not. That is not equal, which means it's false. So what does that mean? It means that clearly 5 is not the solution. Let's try. We could keep going. You might have already worked out what the solution is. What number? Thankfully, it's a whole number. But we're not always going to get whole number solutions as we get into more advanced sort of maths. Let's try this way. Let's have a look. We've got 26 is equal to 3z plus 5. Notice that I want to get z by itself. Now, so far, what we've got is we're working our way up in BODMAS. Let's write BODMAS again. Now, notice that with 3z, we're adding 5 to 3z, and when we work our way and evaluate, we're really starting to think in this direction. We want to go in reverse. We want to work our way and find our solution. So I've got addition. I've got add 5. What's the opposite inverse of adding 5? Well, we can subtract 5 from both sides. Okay, so 26 take 5 on the left-hand side is 21. And if I take 5, that's going to cancel out, and we've got 3z is equal to 21. Now, I've dealt with my addition subtraction. Now we've got division and multiplication. Z is multiplied by 3. What is the opposite of multiply by 3? The opposite of multiply by 3 is divide by 3. So if I divide the left hand and right hand side by 3, we're going to get our answer. We're going to find what z is. See, have a look at this. What happens to the 3's? They cancel out. So we're left with z is equal to, oops, I didn't divide the right hand side by 3. Okay, so you can see there z is equal to 21 divided by 3 is 7. That is our solution. If we guessed and checked, if we would eventually come around to, okay, does 3 times 7, we tried 5 before, now let's try 7. Does that actually work? Yes, it does, because 26 is equal to, is this garbage? No, it's not. 26 does equal 26. That is a true statement. So my solution is z is equal to 7. When you're asked to find the solution, we're trying to evaluate, find the answer, find the pronumeral. That's what algebra is all about, is finding our solution. All right. So look, I'm just going to leave these ones here. I'm going to get you just to pause it now, and in your notes, hopefully you have those in front of you. Can I get you just to quickly try these and pause it now, and I'm going to go through and review my solution in a second. All right, I hope you had a go at that. Let's have a look and go through this. The number k is double. Now, we went through a little bit this in our PowerPoint exercise we did last class, the mathemagic. the number k is doubled. So let's do that. The number k is doubled. We've got to turn this into an equation. So we've got 2k. 2 times k is 2k. Then 3 is added to the result. Okay, and 3 is added to the result. And the result is 52. Now, sure, if you want to guess and check at this stage before I go through, equations further and looking at and solving 1, 2, and 3-step equations, then that's fine. You could guess and check. You could say, okay, does k equal 10? Does k equal 10? Clearly, no, it does not. We could work our way up. We could keep going and going with this. Now, all right, let's have a look at doing this. Now, again, it might be, so we've just written equations. Oh, we've just written the equation. That's all we're after for the time being. So we haven't been asked. Notice we haven't been asked to solve. I've jumped the gun there. Now, we could indeed solve this if we want, and we probably will do that. If we did want to solve this, notice here that we can't, there's actually no whole number that is going to make this work. So if we tried the whole number, we're going to have some problems with guess and check, and we'll sort of look at that a little bit later. But by all means, if you wanted to try this now, what's the opposite of add 3? That would be subtract 3. So we're subtracting 3 from both sides. I've got 2k is equal to 52 take 3 is 49. What's the opposite to times by 2? That's divide by 2. So in actual fact, our solution, if we were asked to do that, is going to be 49 divided by 2. K is equal to 49 divided by 2, which if I'm thinking in decimal world, we're thinking about 24.5 would be the solution to this. Think about I've divided 49 by 2. You could do that in your calculator. That is our solution to this. Really hard to guess and check when we're looking about decimals and things. So I'll just go through one. Now, by all means, you can keep that in the back of your mind. This is where we're heading. I'm not asking you to tackle things like this. We're just asked to, first of all, we've got to be able to set up these equations. Now, Kira works an hours earning $12 per hour. So if I was to multiply 12 by n, that would be she's earned $156. So how could we go ahead and find this? Well, if I wanted to find n, what would I have to do to both sides? Well, n's multiplied by 12, so what's the opposite of that? It's divide by 12. So if we wanted to solve this equation, we'll stop there, but we'll have to solve it that way, and guessing and checking is not really going to work. We know that 12 12s are 144, and I'll just tell you that 13 12s is an extra 12. That's 156. Well, we could probably guess and check that, couldn't we? We could then say, okay, well, 13 12s are 156. That means that I could guess and check that a bit more comfortably. That would be that n would have to be 13. If I was asked to find a solution, that's one way to do it. Okay, so, all right, girls, hopefully that's enough. I'll get you to, by the time you copy this down, you can try a few questions if you like. I will see you after the break, and I hope you have a good break. And if you wanted to finish this off, the 7A questions for homework, you're welcome to, but I'll certainly give you a little bit of time in our first class in term 2. All the best, and I'll see you after the break. Hope you get plenty of eggs for Easter.